Hello everybody. Let me present Tony and Tushar and the Savage Curtain.
Alright people, our presentation is on the topic of mobile SSL failures. We are really excited to be here at BSides, and this is my first talk ever at a security conference, so thank you all for the opportunity. So our plan is to showcase in the next 45 minutes or so some of the systemic issues we found in popular mobile applications and operating systems. Also, we will be presenting a new technique of achieving almost undetectable and persistent man-in-the-middle capabilities in certain iOS and Android applications. So a little bit about our background. I'm Tushar Dalvi. I have with me Tony Trummer. We both are senior security engineers at LinkedIn. And we are primarily responsible for vulnerability research and penetration testing at LinkedIn. But like most other security folks, we spend most of our time herding cats. Previously, I worked at McAfee as a security consultant, and I also got my master's from Johns Hopkins in information security. Tony, on the other hand, is a serial dropout, comes from a military and networking background, and has almost 20 years of experience in IT. And just to be clear, this presentation is purely a part of our side project research work. And so our opinion does not necessarily reflect the views of our employer. All right, so the premise of this presentation is that mobile applications have come a long way from what they used to be. And they offer so much more control to the developers to define their exact behavior. And in most cases, an application would be written for several different platforms. You have Android, iOS, Windows Mobile, and so on. And of all the problem apps we found, most of them were in Android. We did find a few in iOS, but surprisingly, we didn't find any on the Windows platform. Since each of these platforms have differences in the way they offer they can do the exact same thing in different ways. The developers need to have a clear understanding of what the implications might be for the flexibility of to do the exact same thing on different platforms. And this is especially important because if it comes to security controls such as SSL. So speaking of SSL, since most of us are familiar with the concept of SSL, let's try to recap the basics in, let's say one slide. So SSL provides two key benefits, right? First is the secrecy or the encryption of data. And then we have authenticity, which guarantees the identity of the entity that you're trying to connect to. So typically in the event of an SSL handshake failure, browsers would typically show a browser warning saying, this is probably not the site that you're trying to visit, and so on. And so you get a gist of it. But in mobile application, this safeguard is left at the mercy of the developers. And that has some security implications, as we would see. And if you think about it, SSL is the only real protection right now against preventing man-in-the-middle attacks. And they are sort of significantly easier to carry out on mobile devices. And we have certain reasons to believe so. The fact that most users' cell phone data plans are not unlimited, the connectivity speed is significantly slower over cellular networks as compared to open Wi-Fi networks. And so the users usually have a tendency to hop on to any open Wi-Fi network they find and would stay connected for as long as possible. And cell phone providers actually encourage this to save bandwidth. And this is the reason why your iPhone automatically connects to any Wi-Fi that's called ATT Wi-Fi. And some previous research has shown that even without you actively trying to connect to an open Wi-Fi network, the device itself would try to communicate to any pre-configured or any previously known set of SSIDs. And also, if you guys are aware of the Snoopy framework, it's designed specifically to look for Wi-Fi probes for such devices trying to connect to open Wi-Fi networks, and then tries to imitate as being the same Wi-Fi network so that users can connect to that network. So we'll show why if an attacker can lure a victim to join the same network as them, or worse yet, a network that they control, it's essentially game over for them. And add to this the fact that researchers recently claimed to have cracked WPA2 encryption. So many of you would be thinking, what are the chances of such a large-scale man-in-the-middle attack taking place? And well, as a matter of fact, Nokia was found to be performing the exact same thing in 2013. And they reportedly did this for performance reasons. But just think about this for a minute. The manufacturer, one of the leading device manufacturers, had the capacity or was actively intercepting and decrypting their customer traffic. And also, let's not forget that according to allegedly leaked documents, the NSA and GCHQ were performing similar man-in-the-middle traffic, snooping SSL traffic. So the real question is, how do companies show their customers that they really care about SSL? Well, turns out many of them, just put up these logos on the website without actually considering, what they are promising to their customers. And naive customers or naive consumers, on the other hand, have, a reasonable expectation that these signify that their data is immune to eavesdropping. So we are not lawyers, but it turns out that stating that you use SSL on your communication in this way, or even in as a part of a disclaimer, turns out to be legally binding, which we'll discuss later. And the fact that encryption is just a part of security and not the end of it. So one night after a few drinks, we decided to start hacking some mobile applications. And as usual, we started by examining the traffic that flows in and out of the device and used by the applications. So then we noticed something very strange, like strange behavior. So Tony will now discuss the details of what we found.
Thanks, Tushar. Hello, everybody. I'm Tony. Hopefully you're enjoying yourselves at B-Side so far. Before getting into exactly what we found, we just wanted to make sure everybody, is obviously on the same framework. Not everybody's necessarily a deep technical person. In general, in order for SSL to validate the identity of the remote side of a conversation, it checks that the certificate it receives is cryptographically signed with a private key that corresponds with essentially a public key that it already trusts, a certificate authority's public key that it already trusts. Companies like VeriSign, DigiCert, GoDaddy, and all of them are generally automatically included in these stores. Obviously, the entire trust model falls apart if any random attacker could spin up a CA, create a certificate for www.google.com, and the victim's browser or app would accept it, right? So before proxying mobile SSL traffic, as anybody who's done this knows, you have to install the proxy's CA certificate into your device so that it will trust it, right? Since it's generally not already trusted. For example, we use Burp Suite all the time, and this would be the port swigger CA. Anybody who's ever done this knows this. So having established these facts, what we initially found was that we were still seeing traffic in our proxies despite not having installed the port swigger CA on our device. So something was wrong. It turns out the reason we were still seeing SSL traffic was that sometime during the development process, the validation of certificate authorities was disabled. Unfortunately, this is a common practice, and it may have been done due to developers not fully understanding what they were doing, or simply because they disabled it for testing because they wanted to proxy their requests and were too lazy to install the certs on their devices or emulators or whatever, and then just forgot to turn it back on. So since you can, install certs on your device or your emulator, there's no real reason to do this in code, but we just think it's an example of just because you can do something in code doesn't mean you should, right? To be clear to anybody who didn't follow, At this point, an attacker could simply have gone down to the local coffee shop or any place with open Wi-Fi, join the network, gain man-in-the-middle position via either ARP cache poisoning, DNS cache poisoning, ARP spoofing, something along those lines, or alternatively gone anywhere and just set up their own hotspot with a common SSID, and a device may have connected to it, right? They even might have set up their own femtocell and just waited for victims to connect to that. There's plenty of strategies. There's even a drone now that will fly around and follow you and broadcast SSIDs to you, so they could potentially just hover above you, owning you all day long, right? So, where was I? At this point, basically, an attacker on the same network or with man-in-the-middle position would be able to intercept and decrypt all of the traffic for all of these apps. At this point, Tushar and I were probably thinking, wow, we're really cool. We're like the next generation elite hackers, right? We found something really cool, and then our boss is like, no, there's a paper that came out in 2012 called "The Most Dangerous Code in the World." If you haven't read it, you should. But essentially, it talks about failure and SSL certificate validation in many platforms. Anyway, not being discouraged, we decided we'd push on and just see how common these issues were. So, first of all, we'll try to, as a disclaimer, we'll try to avoid naming companies by names simply because they didn't validate our findings or never even respond to us. Some companies, right? But we feel we did our due diligence in making sure that they were the actual apps and that we did contact them and then we validated results, et cetera, et cetera, et cetera. But there is a phenomenon in the app stores where some people just make fake apps, right? They'll just put up a logo and say, hey, it's bob@gmail.com and I published the Gmail app, right? And some people will download it, right? So it's always possible we got an errant result, but we didn't actually find that, but just in case. We don't want to get sued, right? So when we selected the apps, we obviously try to focus on the top apps, generally by download count. And we thought, we were going to focus on the ones that led to interceptions of passwords, significant session tokens, credit cards, or something, some piece of sensitive PII, right? Not just, oh, I can change the page you looked at or something stupid like that. So unless we specifically state what could be pilfered, we're just saying there was an issue with the app, partly because we don't have time to go through each case and mostly because we don't want to get sued by anything if we misstate anything. So in total, we found about 10% of the top apps were vulnerable to this problem. The problems, I should say, that we outline here, in some sort of immediate and meaningful way, right? Like you could do something really bad inside the app, not just shenanigans, right? We didn't necessarily include all the apps we found, simply for the fact that if you're using bad SSL but you're not doing anything sensitive, yeah, I could stuff some JavaScript in the responses, or I could send you a malicious redirect or something silly like that. But that's inherent with HTTP traffic as well, so it didn't really seem to be noteworthy. So moving on, you might be thinking, well, these aren't really like the top apps, and clearly, some of these companies aren't very big, or maybe they're big but they don't really have a significant IT security presence or something along those lines. But again, this is just a taste. So, as with tribbles, bad coding practices just seem to multiply uncontrollably, right? Unfortunately, while, for example, the Windows Phone may have fared well in the apps that were published for that platform, Microsoft's own apps for other platforms didn't do so hot. They were, don't get me wrong, I'm not a Microsoft basher, but they were probably the top offender that we found. It sort of makes sense if you think about probably the number of apps that they might have, and any place with a developer-driven culture tends to, let the inmates run the asylum, right? So another noteworthy thing up here, the Google Cloud Messaging app, or it's really a service. So this represents a service that is used by nearly every Android app in the world, right? And what it does is basically how the app registers with Google for receiving push notifications. It's only half of the equation because you generally still have to register with the app servers, the app developer's server, to get the actual messages. And I'm also told that it's used by all the Chrome extensions too, so it might actually have been in the Chrome library somewhere that this bug was, but we didn't dive deep into that. I just wanted to point it out. Since we didn't really figure out how to exploit this in any meaningful way, we just figured it was noteworthy, so we'd include it. Taking a look at the other apps we found, we thought to ourselves, you wouldn't really have any problem unless you went and bought some shoes or some books or electronics, or used one of these like credit card, went to some store that was using one of these credit card swipers, or bought movies, or went to your bank or manage your investment portfolio, access your home security system, maybe your networking vendor support site, your help desk, the largest payroll provider in the country, use one of the numerous vulnerable two-factor authenticators, made a conference call, access your ISP account, your corporate VPN, or logged into your Microsoft account again with either your Bing or Outlook. I'm not sure why you need to log into Bing, but it's there. Just because I like these guys all of a sudden, I just give a shout out to the Zappos staff, who were like one of the few people who were like, oh, we know exactly what's wrong. We didn't have to handhold them through the process and explain why this is what was going on. They were just like, boom, got it. And we got free shoes. So, moving on. So, if it wasn't clear, if you don't know how to test for this, call Scotty and he'll tell you. We'll be posting this on a site we put up, secbro.com. Don't worry if you can't write this down, but basically you can just use Burp Suite out of the box with the default proxy settings. It generates a dynamic certificate signed by its CA to match whatever host name you're trying to reach, essentially. So you basically just configure your device to proxy through it, step through it. If you see SSL traffic, there's a problem, right? That's provided you did not install that certificate, the port swigger CA certificate on the device first. And if you have, you want to either way, you want to double check that you see a cert warning if you visit a SSL protected site in the native browser, just to make sure that it would throw up a warning if something was wrong, right? So of course, after looking at these, we wanted to see, well, what else could go wrong? So we sort of just stepped down the certificate validation chain, right? Like what would you do next, right? So the second aspect of validating certificates is basically, does the subject common name or alternative name match the host name of the site that I'm trying to contact, right? So this entire trust model falls apart if anybody could go to let's say DigiCert and get foo.com, and then your app accepts it even though they're trying to go to google.com or whatever it is. The example we gave was that, if the certificate for NSA.gov was accepted when you were trying to visit torproject.org, there's probably going to be bad times ahead for somebody, right? So while these apps all correctly validated the certificate authority was someone that they trusted, they never bothered to check that the name on the certificate they received actually matched who they were trying to talk to. So we went and got a free certificate from startssl.com for our domain tmitm.com, and basically just offered that to all the apps and said, who wants to still talk to us, right? So to be clear, startssl.com's CA is already trusted out of the box on both iOS and Android, so we didn't have to install the cert first, which we thought made the testing more pure and easier to understand and more valid. There is a way you could do it in Burp. There's a configuration you could do Burp to basically do the same thing, but I just didn't want to mess with that. I thought this was a cleaner example. So again, looking at the apps, we see several significant financial applications, tax software, the leading blog software's admin app, a domain registrar, and ironically a SSL certificate authority, an ISP, some security software, cable television company, one of the biggest Chinese internet companies, the California DMV, which sucks for all of us who live in California. And note, if you do see an app on multiple slides, it's because it had multiple problems, or it was vulnerable to different things on different platforms. We don't really want to waste the time in what this was iOS and this was Android, etc. So, Oracle wanted us to let you know. We got a lot of people. Please say how well we did it fixing this, and we did it quickly. And if you have to include us, tell everybody how awesome we are. And we basically told them all to go away. But Oracle told us they chose the nuclear option and just got rid of the app. So the Oracle Now app has just gone out of the store. And the folks at Citrix want us to tell you that the Citrix Receiver app was some sort of demo, and there was no, in their opinion, there was no customer data ever at risk. So okay, I have no problem with that. So we also had some interesting experiences, namely AT&T. We submitted this information to them, and about 4 months later, they came back to us and they said, "Yeah, seems fine." And I said, "Okay, well, at least with the first one, the My AT&T app." So I I said, okay, well, you say it's fine. I'm going to go check it, right? Do my due diligence. And I checked it, and I happened to notice that it was updated the Friday prior to the Monday that they contacted me, right? And I was like, oh, okay. I see what you did there, right? So, yeah, it's fixed, I'm sure. So I'm just going to exclude all their apps. I found some replacements, so no big deal. And then Yahoo, I don't want to bash them as bad, but similar kind of experience. I told them 4 months later, they got back to me and said, it looks fine now. So, okay, found someone else. Yeah, so we had some funny trials with some of these. Anyway, as you can imagine, a lot of people contacted us, didn't want to be in any kind of presentation regarding bad security practices. But anyway, stepping through this, again, I pretty much explained it, but obtain a valid certificate for any domain, use custom certificate option in Burp, plug it in there, right? And then just configure the listener to go through your proxy, configure the device to go through your proxy. If you're still seeing SSL traffic as you pop through it, something's wrong, right? Again, I always caution to make sure you see a certificate warning in the mobile browser just to make sure everything's as you expect it, that it will fail. There's always a chance the mobile browser could be broken too, but we didn't see that, so luckily. I'm skipping ahead, sorry. So when we were doing this is probably like in February, March when we were wrapping up, and that was about the time that this go-to fail bug came out for iOS, and we're like, well, fuck, you can man the middle of everything on iOS for years, so what the fuck difference does it make if you can, man the middle of a certain app, right? So rather than trying to explain to people like, oh, well, it's not that, it's this, we figured that was going to be pretty hard sell to people, so we're like, forget it. We'll just leave iOS alone and whatever. And then we saw an Ars Technica article came out, which it looked like some people might have been doing research similar to this. So we said, well, we're not going to keep going down this road and like duplicate efforts or whatever. And obviously they decided to go media with it, where we thought that more responsible disclosure probably was. We thought of maybe, I don't want to get in a flame war with anyone. Just we decided to take a different app. Okay, so we did, however, find another way in which some apps fail to use SSL correctly, and that was by not using it at all. So, at least not in important requests, right? This included leaking session tokens from Quora, a popular information sharing application for, luminaries or something like that. The entire registration process for the Cisco WebEx app, including the password creation, wasn't encrypted. The usernames and passwords for Angie's List Business Center, which is probably no big deal, it had like 5,000 downloads. Was not encrypting stuff. Again, the usernames and passwords. Now, there's an application called Rockbot, which we use at our work. It's basically like a digital jukebox, right? You can buy credits to like sort of upvote your own songs or something like that using credit cards, right? So those were also not encrypted. But then we found one that we thought was particularly interesting, and we consider it pony-worthy. So, of course, to be pony-worthy, first of all, we hope you enjoy the animations on this slide. Just it cost us several $1,000s, so we wanted to ensure we got our money's worth. Obviously, for an app to be pony-worthy, you have to leak credit cards, right? So we had unencrypted credit card information. Difference here is that they're a tier 1 PCI merchant, right? So we're talking about scale, and then. Obviously, tier 1 status means you process lots and lots and lots of credit cards, right? I'm pretty sure, last time I looked at a PCI checklist, there's something about encrypting using SSL in there. I'm not 100% sure on that, but I'm pretty confident. So their installation base was more than 10 million users, right? So that was probably bad news for a lot of people. And as you'll see, it's probably an application that most of us use. I know I do, so... So who was it exactly that forgot that HTTPS ends with an S? Redbox. You guys probably all know them. They're the little video rental kiosks at all the 7-Elevens and all that, supermarkets and all that stuff. So you could have, milked people $1 at a time or something like that, like they do. But anyway, just to show you, I know it's blurry as hell, but oh well. You can clearly see here there's a post to API/account save card going to http www.redbox.com, right? And I'm highlighting there the full 16-digit credit card number. It's not my real one, so it's a fake number, so don't try to steal it off of there or anything like that. But we thought, this is a pretty good representative sample of all the fucked up apps in the app stores, and we figured, it was good enough to underscore the needs for improvement in the mobile SDLC regarding transport layer encryption, right? There's several different ways you can fail, and we obviously want to encourage anybody who's got an icon that looks like anything on here to make sure that they've updated to the latest version, and it should be fixed. Let's see. Ideally, we wish these companies would have to come forth and sort of notify their customers that while their data wasn't actively stolen, it was leaked all over the place, and there are plenty of opportunities that somebody could have pilfered this stuff. Again, your mobile devices are transient by nature, right? You're always bouncing in and out of networks, whether you know it or not, right? So, why this is so important? Getting back to those SSL usage disclaimers made by the many sites and apps that you see, we're all familiar with these padlock things, right? That Tushar was previously talking about. Well, during our research, we found out there was previously FTC suits against Fandango and Credit Karma for essentially the same thing, right? Promising to use SSL, but then not validating SSL certificates properly. That was one of the main citations from the suit. So obviously you won't want your company to go through this. And what ended up happening was that the company settled with the FTC, and in addition to being publicly scolded by them for breaking security promises to their customers, they were compelled to institute what was termed comprehensive security programs, which you would think companies should have anyway. So I'm not exactly sure what that means, but unfortunately, it also came with a 20-year penalty, essentially an oversight by the FTC, where they're going to be in their business for the next 20 years, which is a pretty stiff penalty, right? So what ends up happening in this situation is when you're under FTC, guidance, let's say, if you fuck up again, the penalties are worse, right? Because it's not your first offense. So hopefully there's no one here from the FTC, at least for the sake of the companies we've shown here. I don't know how actively they pursue this, but if you've ever been to a security conference, you knew this was coming, right? We didn't want to leave out the tinfoil hat crowd, so sorry, Bones. But so there's this thing called SSL session caching, right? If you're not familiar with what this is, it's an effort to make SSL handshakes or the overall SSL process from start to finish more efficient and faster, right? So someone decided the way they were going to do this, it was a good idea that if we just validated that the site that we wanted to talk to was the right site the first time we handshaked with them, right? We don't have to do it again, right? Because we already know they're the good person, right? So what they do is they basically validate the certificate the first time, and then they just cache this, right? And then they say, okay, we can talk to you by storing an identifier of some type, right? They just keep talking to them. We found that Google Maps was the app that we were testing on, had this feature enabled, as many others do. So we thought to ourselves, okay, so well, what if a bad guy could make that first connection, right? What would happen? So obviously the skeptics say, well, how would a bad guy get my phone? And that's a logical question, and unless you travel and get stopped by the TSA or the customs people, right? You have to give your device to your to law enforcement, like if you get detained by them, have a jealous girlfriend, or got your phone from, or have to give your phone to your IT department. Remember that the tech at the cell phone store and various people along the supply chain already had access to this device. And as Tushar mentioned, Nokia was busted for, playing with their customer SSL traffic in the past. So it's not like it hasn't happened before, and probably will happen again. Obviously, you could also drink too much this week and have your hacker buddies fuck with you. So that's another option, right? So I expect that most skeptics would say, well, if I ever misplaced my phone, I would scour that thing top to bottom to make sure that nobody's monkeyed with it before I started trusting it again, right? And we'll show why that's not going to be as easy as you might think, right? So the reason we think that this is more problematic on mobile, because session caching is not a mobile phenomenon, right? People like to use it on mobile because of latency and bandwidth issues, right? But it's for other reasons as well. So the reason we think it's more problematic here, though, is that just because there are more opportunities for people to get access to your device. They can't get into your data center to get your secure servers, but your devices are all over the place all the time, right? You eventually have to go to sleep. You leave it plugged into a wall charging somewhere or something like that. So obviously most of them have screen locks, but a lot of people don't use screen locks, at least, not security people, obviously. But people use weak screen lock passwords. There are new screen lock bypasses that come out all the time. Smudge attacks are surprisingly effective. And if you ever use your device, like say if you unlocked it in like an airport or a casino lately, somebody's already recorded your PIN code, whether you thought about that or not, right? Obviously, there's the creepy Google Glass people spying at you while you're unlocking your phone and all that sort of thing, right? So it's pretty much a given that somebody's got your PIN, right? Some security camera somewhere captured it in today, even, right? So you might say, well, biometrics are the answer, but I'm willing to bet the cops have most of your fingerprints already for one reason or another. So obviously you ask yourself, well, okay, if I get physical access to the device, there's all kinds of fun stuff I can do. I can install malicious apps. I could just take the data right off the phone. So malware can be installed, but if you have one of these things like Lookout, potentially it's going to detect the malware. You might also ask, well, why wouldn't they just rip the data off directly again? If the apps are foolish enough to store data on the SD card, or if you are, then yeah, you have problems. But if it's not, and generally accessing the data may require you have a rooted device or something like that. Just depends on the platform, etc. But if the device isn't already rooted, or at least the bootloader unlocked, it might require that you wipe the device so the data is not going to be there when they go to get it, right? Or you as an attacker go to get it. So if you're running your device rooted at right now, then you're already doing it wrong and you're probably fucked and don't know. Lastly, so all those things that are attacks against data that's at rest on your device now, but let's say you hadn't quite done what somebody wanted to know about yet, right? You got detained by police, but they wanted to essentially know what you're going to do in the future, right? None of those attacks really help there. So if we can get a cert installed onto your device, it only takes a few seconds. It's a lot quicker than installing an app, right? Now, along that process of installing it, we can also delete it very quickly. And you may wonder why that matters. So, Android latest versions have these little banners that come up and say, somebody might be monitoring what you're doing, right? So, in both iOS and Android, you can delete the man-in-the-middle certificate as soon as you establish that first connection due to session caching, right? Because it's never checked again. And then there's virtually no way for anyone to ever know it was there. Now, like I said, even that network maybe monitor warning disappears, right? So there's no way that you'd ever know that the certificate was there. On iOS, you'll still be able to intercept all the traffic from the device, the application I should say, until the device is rebooted, but on Android it's a little bit different. So in session caching, essentially the server gets to decide how long it's going to accept the cache session for. We verify that we could maintain this ability to decrypt for over 24 hours. And unless there's some limit we miss, we're pretty sure we could probably choose to do this forever, but 2 years is probably forever on a mobile device anyway. So getting back to the Android behavior, unfortunately, the session cache files that Android creates are persistent, and they persist reboots. So that means anytime anyone ever had access to your device, they could have installed a certificate, deleted it, and you have no way of knowing that was ever there. So we refer to this as ever pwning an app, and there isn't much a user really can do to prevent this, since if they do lose physical access or control of their device, even momentarily, right, without having to root the device, because the cache files are actually protected on disk, right? So you would actually have to basically root the device to get to the directory to know that the file was there, in a lot of cases anyway, we'll say. So your really only protection is to basically reinstall the OS altogether, or throw the phone in the fucking trash and go get a new phone if you ever lose control of it, right? It was reported to Apple and Android security teams and that's why we're in the Android Security Hall of Fame, which they just published. So anyway, we thought we'd leave you with a few tips to take back to your organizations on how to protect your apps from these problems. Initially, we thought we'd use the vanilla recommendations of review your code, implement policies saying you can't disable certificate validation or hostname validation even in development and QA. Obviously, test for as we described pre-release. Make sure there aren't any problems. Train your developers. Just hey, it's not that hard to install a certificate, right? I mean, it's like just don't do it, right? And as far as the code review, it's not an extensive list, but code review is basically a grep away, right? You just look for these sorts of things. Again, not an exhaustive list, and I'm not an iOS guy, so you want to look for these sorts of things. Essentially, a trust manager is something that you build, and it's basically it manages who it's going to trust, right? So what they'll do is you look for trust managers that don't actually do anything. They're just empty bodies, right? They just say, okay, fine, we'll just keep moving on, right? There's hostname verifier interfaces. They're commonly they just fail open, where they're like, okay, it failed, but we'll just keep moving along, right? Any use of SSL sockets where there's no call to the get default hostname verifier with the hostname specified, because it'll actually, it's like a Boolean, and if you don't check it, then you'll fail. Some of this is on the Android security website. They obviously realize these shortcomings or possible pitfalls. And again, there's some iOS stuff here as well. So conventional wisdom generally says that in this day and age you should just use certificate pinning in your app, and we don't disagree with that at all. I don't want to state that. But if you've ever tried to mess around with certificate pinning for testing and stuff like that, it's a pain in the ass. That's usually why people don't do it, because they say it's just too much of a pain in the ass. We can't actually protect we can't actually test effectively, right? We're not going to give the production certificates to people to test with, and so we're kind of at an impasse, so we just don't do it. But Tushar and I are both big fans of self-defending code, and what we thought of is to eliminate the chance for a human error. We found what we think is a novel concept, or at least a novel implementation, which was the fact that the IDEs for both Android and iOS have essentially development signing certificates that they use when you're doing stuff in QA and development. Those can't be used to sign apps that you push to the stores. They will reject them, is our understanding. So we thought, well, why don't you build the code that if you need to disable certificate validation in any way, if you absolutely need this functionality, have it check which certificate it's signed with. If it's signed with the dev or QA certificate, you just don't allow it, right? Or sorry, you allow it, but if it's not, then it can't. Did I say that clearly? Sorry. Point being, if it's signed with the QA certificate, it can allow for certificate validation being disabled. If it's not, then it can't. We think that this is a foolproof toggle, so you can't forget something, right? It's not something where you can accidentally leave it on and push it out to prod, and you won't have these problems. And we think it's a simple and straightforward solution that would be unlikely to meet with any realistic objections. So thanks. That's all we have. I hope you enjoyed the presentation, and if you have any questions or comments, we'd love to hear from you. Like client-side certificates? No, we didn't try. We didn't honestly look, because we were looking for the top. Those would be niche case, right? Yes. I did not. Did you double check the iOS one? I assume we did at the time. You got to remember, this was 5 months ago. So, but yeah, they were prompted. As you can imagine, they were. Yeah. So yes on the fix for sure. Prompt fix. And iOS didn't have the problem, as far as we know. Yep. Yes, sir. I have no idea, but yeah, I wouldn't necessarily want to be them. I mean, that's a pretty blatant. I don't. That's why we highlighted them, because generally we didn't. We weren't trying to call out people specifically, but I mean, 10 million installations, and you don't even bother to encrypt. It's just like, come on, that's such a simple thing to miss. It's like. It's unforgivable in our opinion. So, right, so fundamentally, I question why the design models exist that put this in the developer's hands, right? I don't know why you needed to give this power to the developers. I honestly, I could see just retiring this. So the exception to that is so theoretically, if you use certificate pinning, this can be more secure than a person visiting your website, right? Because it's not a general purpose computing application. You can say, yes, I only want that certificate from that CA done, right? And you're good. But why did you need to give them the ability to turn this off in the first place? I mean, it's like, because you can install the certs on the devices and the emulators, there's really no reason for it. So I agree. I mean, it just shouldn't happen.
And that's what we initially discussed. Like, all the different platforms have, given a lot of flexibility to the devs. And so, these kind of problems do come.
So we also found some apps will actually have a toggle in there, trust all certificates. So they were aware that they needed the functionality and they solved it in a different way. And Windows Phone, I think the Windows Phone actually, or the one we were testing on, actually had that toggle as well on the device level, which was kind of interesting. Yeah, those. So those were some of the things that would cause you potential problem, right? So again, I'm not an iOS expert. I'm just good at Googling. So yes, handsome man in the third, fourth. So we tried looking at exactly. So I played with it, and I was able to control the lifetime of the client, how long the client would hold on to that, right? And right. So when I actually examined the session file, and I admittedly didn't give it a thorough, scientific investigation, but when I investigated it, it basically looked like the certificate, like it just had pulled down the certificate. But there's got to be there's supposed to be an identifier in there somewhere.
Some sort of TTL.
Yeah, there's a TTL, but also an identifier to say, hey, this is the session I'm trying to resume. So the quick answer to this question, I don't know.
Right, and then that. Right.
So we also, I winged some of the slides and didn't cover it, but we theorized that there's got to be problems with apps accepting expired certificates, revoked certificates, not recursing the chain to make sure that's actually a trusted root, right? Like, right. They're out there. We know it. It's just. Because of some of the other stuff that was going on at the time, we didn't pursue it any further than that. Anything else? Yes, sir. They were far better.
Yeah. Most of the problem.
I hate to admit it.
Yeah, most of the problem apps were Android. A few were iOS. Very little.
Yeah, we thought we were seeing about the same rate initially, but. We weren't. So it really was primarily an Android problem. But it's not a problem with the platform. It's the problem with the app developer, right? So maybe people who develop for Android aren't as good or something like that, or more prone to security problems for some reason. And again, Windows Phone performed Excellent. So if you really want a secure device, go get a Windows phone, right? All right. Thanks, everybody.
Thank you.